Good afternoon. Okay, today we are working on composite functions or composing functions or composition of functions. It is a two-part assignment, or this is a two-part note page. Today we're going to be doing the algebra of compositions, and then on Monday we'll be doing the graphs and the function tables. You'll enjoy that a lot more, I'm sure. But today we're going to focus on the algebra. So your objective, you will be successful when you can read the composite function notation, perform a composition, and evaluate a composition. So composing, what does that mean? We're not talking about writing a paper or writing some music. We're talking about composing some math. It's really beautiful when you graph it, but it doesn't really sound beautiful. When you're composing, it's just the act of plugging one function into another. So here's the thing. Listen, when you all see a math problem and you see 5 minus 2, you immediately know to subtract, right? I mean, immediately you know what to do. If it's 5 plus 2, you immediately know you add them. If you see times 2, you multiply. And if you see divided by 2, well, you go, okay. And you don't even question it, you just do it. We need composing to become as automatic as adding, subtracting, multiplying, and dividing. So let's really focus on learning to read composite function notation and identifying immediately what you're being asked to do. So composition notation looks like this. Sometimes you'll see it in this form, and that shouldn't be that big, so I'm going to back that up and try it again. So the f of g of x is telling you to plug g into f. That's what it says. So it's alternate form. I prefer the alternate form looks like this, the f of g of x. I like that form better because it gives me the visual that I'm plugging g into the f function. So it's really important that you learn to read them both, that you recognize that this little symbol right here says compose. It doesn't say add, it doesn't say subtract, it doesn't say multiply, it doesn't say divide, it says compose. That's what it says. So I'm going to color code, move my menu out of the way a little bit. I'm going to be color coding today, but before we do that, I do want to mention one other thing that we'll put over here in the left-hand side. I'm really interested this year in pre-calculus on your ability to identify the domain of whatever functions you're creating, because you're already supposed to know how to compose functions. This has got to be your third time composing functions. I mean, your third year of composing functions. So we'll be composing more complicated functions than you've done in years past. But my concern is, can you identify the domain? Because that's really important. So here's how I'm going to give you some tests for the domain. So here's the domain tests. Test number 1, what's the domain of the inserted function? Because just like when we're adding, subtracting, multiplying, dividing, we have to look at where do our functions overlap. So we need to identify that. And test number 2 is, how about the final function? What's the domain of the final function? We're looking for where the two overlap. Where do they intersect? Because that'll give us the domain of our composed function. Okay, so those are our tests. This is how we determine what our domain is going to be. So would like you to always, when we're working with functions, first clue into, okay, what is the domain of our f of x? So I'm going to be doing my f of x in black pen today. So first let's identify. This is a quadratic function, so its domain is completely unrestricted. Any x I want, I can plug that in. There's nothing I'm not allowed to use. Okay? And I'll be doing my g of x functions in blue. Now this g of x function is a linear function. It is also completely unrestricted in the domain. I can plug in any real number that I want. I am not restricted. I'm free to do what I want, to pick what I want. Okay, so when I see this first problem, it says find the f of g of x, including the domain. I am not a fan of this form of composition function notation, so I'm going to rewrite it as the f of g of x, which is telling me I'm going to be plugging, notice I changed colors because I like to color code things here, the g of x into the f function. That's what I want to do. Insert function 2, the g of x, into function 1, the f of x. So here we go. I'm going to take my f of x, which is x squared minus 1, and remove the x, but keep everything else, and insert the g of x, which is 3x plus 5. That is actually, there's an interim step that I missed that I want to include in there. So I'm going to write it down here, and then we'll just do a little arrow. So we're going to go down, and then I forgot something that I really want to do. Here's what I really want to do first. I want to plug in the actual function of g of x, which is 3x plus 5. And then do that. I wish this was my old program, because then I could just scooch it over. Okay, so it'd be nice if you could finish there, and when you get to calculus, you get 2. But in pre-calculus, you still have to do some math. So we're going to use our algebra skills here, and we're going to expand. So this is 3x plus 5 times itself, minus 1. We're going to simplify. Simplify. I will tell you that I am at the point now where I really want you to be able to square a binomial without expanding it first. So here's how I do it. When I'm squaring a binomial, I know I'm doing squaring the first number. 3x times 3x is 9x squared. And then if I expand it, I do my outside multiplication plus my inside multiplication, which is 15x plus 15x. Well, without expanding it, this is what I do. I square the first number, 9x squared. I multiply these two twice. 15x plus 15x is 30x. And then I square the last number, plus 25. It's always the same process when you're squaring a binomial. I'm going to do it one more time. You square the first number. You multiply the two parts twice, and then you square the last number. That's what you do. Let's finish this out. So this is going to be my f of g of x, finalized 9x squared plus 30x plus 24. Okay, so that's my composition. I need another parentheses there. All right, now what's my domain? Let's talk about that. Let's go back to our domain test. What was the domain of my inserted function? Negative infinity to infinity. Yep, that was it. Now it has to intersect with my second function or my final function. What's the domain of this parabola right here? Negative infinity to infinity. So where do they overlap? Everywhere. That's right. So my domain is still unrestricted. But it's really important for you to be clear about that. All right. Shall we do another? Let's do another. Let's do it. All right. So this one's already written in the composition notation that I prefer. So we are going to be doing the G. And it's already ready to go. I'm going to insert my f of x, which is what? X squared minus 1. I'm doing the g of f of x, and the f of x is x squared minus 1. So I'm replacing this double set of parentheses with a single set of parentheses. All right, so let's go. So this is going to open up. We're going to open up where the x is. So we'll remove the x. So 3 times this quantity plus 5. And we are inserting for our x, x squared minus 1. And then, of course, we'll simplify that equation. Are you ready? I don't have to square that. All I have to do is simplify or distribute. You agree? All right, so let's finish that up. So the g of f of x is equal to 3x squared plus 2. Let's go back to look at our domain. Our original domain had a restriction of nothing, right? And our final domain is also a parabola. No restriction. So what's our domain? You got it. And beyond. Is there a beyond infinity? That's what I want to know. What's on the other side? How can it even have another side? This is a question, just gives me headaches. Okay. Here we're going to evaluate. So we've looked at the different function notations, f of g and f insert g. And now we're going to evaluate the function where x equals 2. And there's 2 ways we can go about it. So I want you to stick with me for the first one, because this will be helpful next week on Monday. And then you can tell me what you would have done instead, because you probably already have a plan. So here we go. We're going to do the f of g of 2. What's my g again? But I'm replacing the x with a 2 plus 5. That's what I want to do. Think this is a pretty clean way to do it. It's a different way. And that means I'm doing the f of 11. Because I can simplify that because I'm actually plugging a 2 into my g function. So I'm evaluating here. Okay, and the f of 11 means that I'm going to put an arrow there to indicate that I'm moving forward. The f of 11 is 11 squared minus 1, right? Because that's my f of x, x squared minus 1. I'm replacing the x with an 11. So let's simplify that down. That's 121 minus 1. And so the f of g of 2 is 120. That might not be the way that you thought about it. How did you think about it? Yeah. So you went back to problem A because we'd already found the f of g of x, and you plugged in the f of g of 2 into your function 9x squared plus 30 times 2 plus 24. And this is absolutely an acceptable way to solve or evaluate this function. And I'm okay with that. I'm okay with you doing whatever you've got to do to get the answer, as long as it's right and you didn't cheat. I'm all right. So that's also interesting, 120. One's a little more direct or a little quicker mathematically. The other one is a little more direct and is connected to what you've already done. And I'm not going to tell you what to do. I'm just telling you have options. Do what makes the most sense to you. Okay? All right, let's do this next one. This is the way I'm talking about. This is the way I was assuming you would do it. Okay, so let's look at example 2. Let's look at some domains real quick. Again, my f I'm doing in black and my g I'm doing in blue. What's my domain for my parabola here? Unrestricted, okay. And then how about my domain of my g of x? That's supposed to be blue. Pick up that blue pen. What's my domain? Open or closed? Closed. 0 to infinity, right? Because we can't put negatives, but we can put zeros underneath square roots. Okay, so we have our domain restrictions. And on our first problem, we're doing the f of g of x. But we know what the g of x is, right? And this is supposed to be black. Let me get my black pen. Really struggling with my technology today. Not selecting when I ask it to. Okay, so I'm doing the f of what? What am I plugging in? Square root of x. That's what I'm plugging in. I'm replacing my g of x with its actual function, the square root of x. Okay, so we're going to go take out the x in our function f. We're going to insert the square root. And I think I'm going to indicate my domain right now. What's my domain restriction? 0 to infinity. I have to keep that in mind because that's my inserted domain. I can't put any negatives in this problem. All right, let's simplify that. So what's that? X minus 16, because square root of a square. So we can say that the f of g of x is x minus 16. Now you might think, well, that domain's unrestricted because it's linear, right? So you might think that. But it was restricted from the beginning. So I can only graph where they overlap. Where do these two domains overlap? Where do they start overlapping? From 0 to infinity. So you have to be really thoughtful and careful. So that one wasn't too bad. Sadly, the next one's going to cause us a little more of a headache. Okay, I know, but I'm telling you ahead of time to prepare and persevere. All right, you're welcome. Okay, so we're doing the g of f of x, and I'm writing it in the notation that I prefer. Are you ready? So that means we're going to plug in, give me my blue pen, the g of what? What are we plugging in? X squared minus 16. All right, so that is just transforming. So I'm going to do a little arrow. I keep meaning to do arrows here. Okay, so I'm just writing it in its alternate form. So that means that I'm going into my g function. Give me my blue pen. And I'm opening up my square root here, but pulling out my x and inserting x squared minus 16. So I'm looking at that and I'm thinking, I don't think I can simplify that. I don't think I can take the square root of x squared minus 16. Now, you might think that it's like x plus 4, but it's not. This is not a perfect square. If I were to factor it, I'm going to put it in factored form so you can see it. It is this, x minus 4 times x plus 4. That's not, see, it's not a perfect square. So you can't simplify it. We could just go ahead and leave it in that form. So our g of f of x is the square root of x squared minus 16. So we started off with a domain. What was our original domain restriction? Did we have one? No. But man, do we have one now? You know we have one. Because underneath a square root, we are restricted from any negatives, right? We can have 0 under our square root. We can have any positive we want. So I suggest we take our zeros that I helped kind of develop over here. Let's find our zeros. Because remember, I think I'll do my domain work in red, and I'm going to scoot my page over a little bit. So here's what we know. X minus 4 times x plus 4, which is just another form of x squared minus 16, has to be greater than or equal to 0. It has to be. Right? Yes or no? Yes. So what are our zeros here? Negative 4 and positive 4. So those are going to create a zeros on our domain. So if I were to graph those on my domain axes, -4 and 4. I could do a sign chart. Absolutely could do a sign chart. We could also just do some tests. So let's test some numbers. Let's plug in a positive, a -5. Plug in a -5. Right here. Right here. What's -5 squared? What's 25 minus 16? Positive or negative? It's all I care about. Okay. So, yep. I want that section of my domain. That's good. Because those are producing, all those numbers from -4 to infinity are producing positive results under my square root. Let's test a number between our zeros. Let's plug in a 0. If I plug in a 0, what kind of numbers underneath my square root? Negatives. I don't want that. Nope. That's no good. Can't have negatives under our square roots and have real numbers that we can graph and talk about. Okay, let's plug in a +5. That's a 5, pretend. It's a 5 squared. There. Positive? Yep, I want that. Because I want positives underneath my square root. So what's my domain? To -4. Closed. Right? Closed. Because I want my zeros. I can put zeros under my square root. All right. So I'm eliminating that section between my zeros because the section between my zeros produces a negative underneath my square root, and I can't have that. So here's our answer right here, kind of hidden, or here's my answer. G of f of x equals the square root of x squared minus 16, and there's my domain. Okay, so here we go. One more time. Now we're going to evaluate. So we're doing the f of g of 4. That's the wrong color. What's my g of 4 again? Or what's my g of x? Square root of x. So my g of 4 would be the square root of 4. All right. So if I'm going through this, give me my blue pen. Man, I'm really getting frustrated with my technology today. Can I simplify that? What's the square root of 4? The f of 2. So that means that I can just go ahead and put a 2 in for x and simplify. So that's 4 minus 16, which is -12. Or we could go through the process because we already found the f of g of x. We could say, all right, the f of g of 2 is equal to, or 4, right? I'm plugging in a 4, sorry. 4. Isaac, are you bored? It's okay. 4 minus 16, also -12. Did you hurt your head when you hit it right now? Because I heard it hit your desk. That's on video. Everybody's going to laugh at you. Okay, we're moving on. All right. You can't zone out now. Even you little smarties. Because we're going to be plugging fractions inside of fractions. And creating complex fractions. They're so fun. Persevere. Good attitude. Have a good I love it. Have a good attitude. Be quiet or I'll give you homework. It's Friday. You want homework on the weekend? Keep whining. Yay. Move on. Okay, so here we go. F of x. I'll do my f of x in black, and let's find our domain restriction. Right now, what is x not allowed to be? 2. So our domain is going to be from -infinity to 2 and 2 to infinity. Open that domain up. Everything but 2. Because 2 will give us a 0 in our denominator, and we can't have that. Switch into my blue pen. Let's find the domain of our g of x. X is not allowed to be 4. So let's eliminate 4. Open that domain up. What's that? Apostrophe. Apostrophes are up here. That's it. Those are commas. Oh, here. I'll move it. There. Better? Typo. Thanks for pointing it out. I'll fix it for next year. Okay. So, listen. We are plugging fractions into fractions, and these tend to be a little bit confusing, so I'm color coding. Hopefully this will help you out. I'm also just doing A. You're going to have to do B by yourself. So, I know. You better clue in. Here we go. So, we're going to be doing the F of what? What are we plugging in here? which is what? Oh, yep, that's right. X minus 3 over x minus 4. All right. So here we go. Don't be afraid. What's that from? That's from something. Is it Peter Pan? Which Peter Pan? Okay, all of them? Oh, I don't remember. Okay, so I pulled out the x's in our function originally up here, and I'm going to replace them with x minus 3 over x minus 4, and another x minus 3 over x minus 4. Yay. Okay, so not a fun problem to simplify, but it's not going to be as bad as you think. So just stick with me, and you're going to be so proud when you can do this by yourself on your first try. All right, so let's simplify this by combining our, let's subtract our numerators. And in order to do that, we have to have common denominators. We're going to do the same thing with our denominator. All right, so we're going to start off with x minus 3 over x minus 4 minus 1 over 1. And you know what I'm going to do? I'm going to pick up my red pen, and that's supposed to be a 4. Let me fix that up real quick. Okay, that's a 4. Jealous denominator over here. What does he want? X minus 4. That's right. And this one over here already has a 1. He just hit it, but it's over there. Okay? So we're looking at that. We go to our denominator, and we're going to go through that same process again. Well, instead, we'll do 2 over 1, extend it out, and the jealous denominator is going to say, give me that x minus 4. I'll take it. So we're going to just add our numerator fractions, add our denominator fractions. Let's keep it really clean and short. So now, I want to subtract my numerators. So first I'm going to go ahead and write them over the same x minus 4. And then I'm going to go ahead and do my numerator. I'm going to subtract my numerators. So I do want you to clue in right here. Pay attention. Look at what's happening on the board. Take that negative and push it up to the 1 so you remember to distribute it. Okay? You don't want to leave that minus there, so just I'm using an arrow. Take it up. And now it's not minus a negative. No, I'm pushing it up so I don't forget it. All right, so we get x minus 3, and negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. So I subtracted the fractions on the top. Now let's do the same thing on the bottom. So I'll write them as a single fraction over x minus 4. And there we go. X minus 3. Again, take this negative, push it up so that you don't forget it. Distribute a negative 2. So that's negative 2x plus 8. Okay, here we go. Simplify. Boom. By x minus 4. We don't want you anymore. You can ask me why in a minute. Let's just finish this out. So, I got rid of those denominators. I just threw them out. Let's simplify this numerator. Add your x's together. What do you get? 0. And negative 3 plus 4 is 1. And then in my denominator down here, add your x's together. Negative x. Negative 3 plus 8. Positive 5. Alert. What's that? New restriction. We know x cannot equal. Well, if you have to do the math, do the math. Negative x plus 5 cannot equal 0, so negative x cannot equal negative 5, so x cannot equal 5. If you got to do the math, do the math. Certainly not going to kill you to take 5 seconds to do that. Let's go back to our original restriction. Don't we have a restriction right here in our inserted function? What are we restricted from here? X cannot be 4. Okay, so those are our two restrictions. Let's talk about our domain real quick. We're looking for the overlap. They overlap everywhere but 4 and 5. So from negative infinity to 4, union 4 to 5, union 5 to infinity. And this is our composed function, 1 over negative x plus 5. So that's our f of g of x. So I guess I could write that over here. But you got it? Do you want to ask me any questions? You know you do. You guys should be asking me why I did that.
Why did you cross out the domain or the
Denominators. Why did I cross out the denominators? Let's talk about that. So this says some fraction divided by some fraction. That's what that says. And it's alphabet soup. It's got all kinds of letters in it. So let me simplify it by doing this. If I were to take this fraction, 1/3, and I asked you to divide it by 5/3, you know that means that I really want you to do 1/3 divided by 5/3, which means you're supposed to keep, change, flip, and simplify the 3's. And that leaves you with 1/5. But if I come back over here and I notice that they both denominators are 3, I can just go like this, 1/5.
That wasn't my thinking. I was just thinking like if they're both divided by the same thing and they're like even because after the same thing, like it's the same way when you have an equation and you do the same thing.
To both sides, yeah. So canceling out. So that's another way to think about it, which is a nice way to think about it. So I like it. So either way, hopefully one of those two ways makes sense. Guess what? Your turn. Off you go. Okay, so here was plugging the information in, and then here is the answer. You didn't do the in-between work. If you can't get the in-between work, go back and do it again. Also finish up this problem by choosing either example 1, 2, or 3, and do the f of f and the g of g. Thank you for watching.